In this video I will showcase this smart plant. I don't really have a name for it yet. What you are looking at here is a planter with a built-in screen. It waters itself using a moisture sensor and a pump. The screen functions as a fancy clock, a calendar assistant and a status indicator. This video covers the evolution of this project over a 1-year period. This project started as a hackathon project for work. There are parts of the build that I didn't film because of the time constraints. The first version also didn't have the self-watering system yet. First I will show the build process and then I will dive into the current version of the software. The main components are a Raspberry Pi and a 7-inch LCD screen. I am testing the hardware setup here. This is the first version of the application and it was written in Node.js. The box itself is made from 12mm plywood. I marked the lines and made the cuts with a circular saw and miter saw. Here I am testing out how it fits together. Then I made the cutout for the screen with a jigsaw. I also made a small hole for the power cable. Then I used wood glue to put it all together. That is all the build footage that I have, and I didn't even film the finished box. I only have one picture of me doing the presentation at work. You may notice that the screen is blank. This is because it broke during transport. Yeah, that was a big bummer. I could show the LED strip changing color and I demoed the software on the presentation screen. Unsurprisingly, I didn't win the hackathon. Back home, it didn't take much time to find out what went wrong. If you look close, you can see that the ribbon cable connecting the LCD screen to the controller board was broken. A few months later, I came back to this project. I replaced the screen, but I also replaced the LED strip and the power supply. I put in some wooden strips to secure the controller board of the LCD screen to make sure the ribbon cable doesn't tear again. I also added a temperature sensor. I did film some of it, but the footage turned out quite bad. I gave it a quick test and after that it was time for that satisfying plastic peeling moment. I finished the box with a vinyl wrap with a carbon fiber texture. You may remember this stuff from my previous video. I carefully measured and marked everything and made the cuts with a utility knife. few months later I did some more upgrades. First, I redid some of the electronics to tidy up everything inside. I also finally added the self-watering system. I created a small PCB that I could put on the Raspberry Pi. It contains the relay for the pump, the main power connection for the Raspberry Pi, and connectors for the temperature sensor. I used hot glue to secure the components after soldering, and this time I also used shrink wrap on all appropriate connections. This is the result. This is the moisture sensor I use. It is an analog sensor and I use an Arduino Nano to send the values digitally to the Raspberry Pi. This is the final result. I also replaced the HDMI cable with a much shorter one. Here is a little watering test. I also completely replaced the software and I will tell you all about it. The current version of the software consists of two parts. A front-end application that is written in React and packaged as a standalone Electron app. Electron is a Node.js framework that allows you to write desktop applications as if they were web applications. It combines the power of Node.js with a browser component based on WebKit. We are not going over the code or anything because that would make a very boring video. All you need to know is that the front-end application is dumb, meaning that it doesn't contain any logic. It uses WebSockets to connect to the backend part, which I made using Node-RED. Node-RED is a flow-based programming tool. You will see a lot more of Node-RED in my channel in the future, because I totally love it and I use it in many projects these days. My entire home automation is running on Node-RED right now, and I will definitely showcase that in a future video. For this project, Node-RED is responsible for three main things: talk to all the hardware, talk to the Microsoft Graph API, and talk to the front-end application. This is the flow that connects it all together. If it looks overwhelming to you, don't worry, I will talk you through every part of it. All these boxes here are called nodes, and the lines represent a connection between them. Messages travel from node to node, and each node can manipulate the message or change its path. The green nodes are debug nodes. They can help me debug problems in the flow. This first part contains all the nodes related to the self-watering system. The moisture sensor is connected to an Arduino, and the Arduino is represented by this Arduino node here. It produces many messages, all containing a value between 0 and 1024. If I turn on this debug node here, you can see the raw values on the right of the screen. This orange node here is a function node. You can use it to create custom logic in JavaScript. I use it to determine if the plant needs water. If the value gets above 500, I turn on the pump for 3 seconds using these other nodes. Determine the value that works for you by trial and error, because it depends on many external factors. I can also control the pump manually by clicking this button here. These nodes are related to the LED strip. This function node takes all kinds of variables into account and determines the color of the LED strip. This node here functions as a timer. It injects a message into the flow every minute. The message itself is meaningless, but it acts as a trigger to start two processes. One is to take a reading of the temperature sensor, represented here by this DHT22 node. The other process the timer node triggers is a HTTP request to the Microsoft Graph API. This is what I use to get my calendar data. If you follow the lines, you can see that both these actions send a message to this node here. This is a WebSocket node, and it sends the message to the front-end application. These nodes handle my work status. I can change it to not working, working from home, or do not disturb. By sending a HTTP request, to webhook relay, an online service to create a proxy for webhook requests. A status request then gets injected into the flow by this webhook relay node. As you can see, it sends a message to the front end and it triggers the LED strip color function. These last parts handle the authentication tokens for the Microsoft Graph API, and this one sets the color of the LED strip on startup. If you want to know more about Node-RED, be sure to hit subscribe, because I will definitely do more videos about it. I hope you liked this video. Please give me a thumbs up if you do. Thanks for watching and until next time.